Hello, everyone, and welcome to UC San Diego Rady School of Management's online masterclass series, brought to you by the MBA MSBA admissions team. Today's masterclass is called Why You Need Business Analytics with Professor Vincent Nijs. Before we get started, I'd like to share some basic information with each of you. Today's class is scheduled to last up to 45 minutes. Questions can be submitted anytime in the chat portal. As your moderator, I may be able to answer your questions immediately or during the presentation. Or to schedule an advising session, please email radygrad@ucsd.edu. Before I welcome Professor Nijs to lead us through a masterclass on why you need business analytics, I'd like to take a moment to share with you the Rady School's mission, which is at the heart of everything we do. Here at the Rady School, it is our mission to develop ethical and entrepreneurial leaders who make a positive impact in the world through innovation, collaboration, and knowledge. The Rady School students, alumni, and faculty over the last 17 years have developed over 180 companies benefiting and impacting the innovation economy of our region, state, country, and world. As our second dean at the helm, Dean Lisa Ordonez intends to transition the school from a startup to focus on growth while highlighting the school's business research prominence and impact as an innovation-focused economic engine within the San Diego business community and beyond. If you're nodding and agreeing with this mission, then you know Rady is the right business school for you. The Rady School graduate program covers a range of disciplines from the MBA to our specialized programs in business analytics, professional accountancy, finance, and even a PhD program. Of these, we also offer the MBA in a flexible format, perfect for working professionals, and have just added the Flex Weekend option for the MS in business analytics as well. The Rady School also has a series of very popular undergraduate minors and 3 collaborative majors at UC San Diego. The graduate admissions process is quite simple, really just 5 steps. First, we always recommend connecting with a grad admission advisor to learn more about the program in which you're interested, to determine your preparedness and potential within the program itself. Given that the final deadline for each of our programs vary, you may want to email radygradadmissions@ucsd.edu to request an advising appointment as soon as possible. Second, you have to complete the application checklist. These are on our web pages and are covered in advising sessions regularly. These checklists give full detail on what you must submit to be considered for admissions. Most programs also have an FAQ page that I highly advise reviewing to be sure you're ready to submit all that you need for the program of your choice. The third step, after you've submitted your application, is to potentially receive a request for an interview. Now, this is a highly competitive program, but for the Flex Weekend MSBA programs, you should expect an invitation to interview if you've passed the initial admissions committee review. This request may come within 2 to 3 weeks of submitting your Flex Weekend MSBA application, depending on our application load. The fourth step would be to accept admissions if it's offered and to submit your enrollment deposit. This deposit holds your seat in the cohort and confirms your commitment to joining the Rady at the start of your program. While these deposits are non-refundable, they do go into your student account upon enrollment in the program, so you can consider it tuition paid forward. And the fifth and final step is to get ready for a transformative professional experience. And now the reason that you've all taken this time to join us is to learn from esteemed Professor Vincent Nijs. Professor Nijs teaches in both the MSBA and MBA programs and is nearly an annual recipient of student awards for excellence in teaching and most valuable professor. He is also the co-creator and co-director of Rady's MSBA program. Professor Nijs's research interests include customer analytics, category management, marketing strategy, Professor Nijs, if you're ready, please lead us through this online masterclass on why you need business analytics.
Thank you, Nancy. Give me 1 second to set up my screen sharing. Now, I know in a lot of events like this, people prefer that participants have the screens off. I actually really like it when people have screens on. So if you're willing to do that, that's great. I love to see your faces. If you're looking confused or bored or whatever it might be, I'm going to see that, and then I'll be more able to respond. Normally, it's also just, whoops, wrong button. We just use chat, but if you have a question, feel free to unmute at any time. Again, you can also put something in the chat if you like, and I'll try to be as responsive as possible. Let's see, almost done. All right, here we go. So before we get started, yes, I do know that I need to update my pictures. I currently look a bit more like this guy, but I'll just blame it on COVID, okay? Most of you probably have no idea who that is. It's Grizzly Adams from a show which ran in the 70s and was rerun in the 80s. Oh, Tim, there we go. So at least one person knows that. All right, so let me jump in here and give you a sense of what we're going to talk about today. So why do you need business analytics? And the answer is actually not all that complicated, but it has a couple of different pieces. And so I just want to jump into those and give you a sense of it. I almost always have more slides that I'm going to be able to get through. So I will definitely share these with you after the fact. And we may skip a couple depending on how time goes. All right, so the value of business analytics today is really driven in large part by the information explosion. And I'm sure you're all aware of that. Right? There's more data that's been generated in the past 2 years than in the entire history of the human race combined. The data velocity is also increasing ever more. 1.7 megabytes of new information every second for every person on the planet. And maybe it's just Tim, but let's see if somebody else can tell me what this is. So you can put it in the chat. Let's see if that works. Okay, right. So I'm interested to see that the first 2 people already mentioned that it's a floppy. I'm anticipating at some point in the future, people will just say that's the save icon and have no recollection or knowledge of what a floppy is. Actually, this is technically not even a floppy disk. It's named that, but it was named after the floppy disk, which was actually flexible. This one is not. Does anybody know the size in megabytes that this would hold? Do you remember that by any chance? Was 1.44 megabytes. So more than 1 floppy per person per second is now being generated. And I still remember using all these floppy disks to install stuff, install games and stuff like that when I was a kid. You'd have like this whole battery of them lined up. Anyway, small digression there. So the amount of information that's available is just enormous. And if you think about the information trail that each of us leaves as we go about our daily business, credit card transactions, online purchases, web surfing, audio video streaming, reactions to mail or email offers, customer support calls that might be automatically transcribed as you go, self-provided information, right? We still use surveys to try to find out stuff about people, location information. Probably all of you have multiple apps on your phone that track your location as you move about, usage information. Think about sensors that might be in your fridge, your microwave, your toaster, your car, wherever it might be, all communicating data back to companies about how you're using their products. And then, of course, all the social media posts, videos, likes, and so on that we all use. And all of this information is fantastically useful for companies. It's really a golden opportunity to create value, not just for the company, but also for the customers. And there are plenty of examples of that. And so I'm just going to give you a couple that I think are pretty interesting. For example, Walmart. Walmart is very, very much a data-driven organization and has been since their inception pretty much. And here's an example of how they use some of that data. So suppose that there is a hurricane about to hit Florida. They don't just wait to see what happens and what might run out in their stores. They actually look at their historical data and create predictive models to try to see what happened during the last hurricane event. And based on that information, they're going to start sending extra supplies to make sure that these Walmarts don't run out of, let's say, water. One of the things that they found in their analysis that's kind of interesting is that the thing that increases almost as much as water in terms of demand when a hurricane is about to strike is Pop-Tarts. Another big one is beer. So I can see the beer, I can see the water, the Pop-Tarts, not quite so much, but it seems to be a pretty consistent pattern that they found, right? 7 times increase in the normal sales rate when a hurricane is about to strike. So that's a productive use of data. A slightly different one is an example from Netflix. So I'm from the Netherlands, and a number of years ago, Netflix was trying to enter into that market. And they needed to figure out, this is a different culture, different country, what would be the best set of shows for them to offer and license. And so one input they used as part of that decision-making process was the popularity of certain shows on pirate sites or file sharing sites. And so they use that not of course as the only piece of information that's available, but at least as one of the pieces of information. Now you can see that there's extremes to this. Like if literally everybody has already pirated the show, there's probably no point in licensing it at all. But you can see that it would be a useful piece of information, and you could compare it to other countries where you are experienced and see how this new country you're trying to enter might differ. And the last example I want to share with you is UPS. Right? And so this applies to all delivery companies, but all of them have this traveling salesman problem that you might have heard of if you in a class previously. So think about an average driver has about 120 deliveries per day. So the number of routes that they could take is enormous. And so what's the most efficient route? Right? So this is a very, very common, very famous optimization problem. But one part of that sort of they do to get away from this is what they call counterintuitive routes, which is one part of that is that they try to avoid left turns. Any idea why they would do that? Why would you avoid a left turn in the US particularly?
Waiting a signal.
Exactly right. Yes.
Signal.
So definitely left turns are more dangerous. Absolutely true, right? Unless it's a one-way street, but that's absolutely true. But the main thing is that it saves time. So in the US, you can turn right on red unless there's a sign to prohibit it. And so it turns out that if you avoid some left turns, of course you can't avoid all of them, otherwise you're going to end up going in a circle or a square or whatever it might be. But they've actually found that they can save a ton of money by avoiding some of the most important left turns. And so that's not something you would get necessarily directly from a simple optimization problem. Obviously, somebody has thought about that, right? And say, hey, we have this route, but somebody deviated from that. They ended up being faster. What happened, right? So these are just some examples of companies that have been very smart and very able with their data. But it's definitely not the case that all companies are doing this, right? So we just talked about the amount of data that's available. So why aren't all companies doing this? Well, to a large extent, they're just not analyzing all of their data. And so of all the data that I just told you about, only about 0.5%, so this is not 50%, 0.5% of all that data is actively analyzed and used, right? And there's a number of reasons for this. Certainly it's the case that some data is collected that we don't really need. I mean, do we really need to know from your toaster every second what exactly you're doing with it in an IoT type of setting? Probably not, right? So in some cases, there's over saving of data, but a big part of that is that they just don't have the right talent. Right? And talent, I would argue, is talent in business analytics. And so we'll talk a little bit more about what that is and how that differs from data science in just a second. So I've been tracking this list from LinkedIn for quite some time. And the first two that you see in this list that I've put in bold are cloud and distributed computing, right? So running any type of analysis on AWS or Azure or Google Cloud, and statistical analysis and data mining. And these two have been either 1 or 2 since I think 2015 or 14, since they started on this list, or at least that I saw them start on this list. It's interesting that in 2018, they added data presentation, which is kind of weird because that seems like it would be a very important characteristic for somebody to be able to do, right? Present the data, but that was added that year. And then in 2019, surprise, surprise, 1 and 2 are still the same. And they've added software revision and control systems. And so this, you might be surprised to learn, is actually pretty darn important in business analytics as well, because to really be flexible and powerful in this realm, you have to be able to write code. Right? It doesn't mean you're a programmer per se, but you have to be able to write code. And as soon as you start writing code, you're going to make changes over time. And those changes you need to be able to track. Right? So think about software revision control systems like track changes in Word on steroids. Okay? So data presentation, of course, still also there. Now in 2020, they actually changed up the list and it broke it up into more different pieces. They explicitly list what they call soft skills. Those, of course, are also very important. And they listed blockchain. Now, I'm very curious to see what happens in 21, 22 with blockchain, because blockchain is kind of all over the place. It seems like it's the most important thing in the world, and then maybe not as much. It varies highly day to day. But they've kind of split up some of these categories. So cloud computing is still up there. Analytical reasoning, artificial intelligence, business analysis, scientific computing, all of those fall within the realm of data science and business analytics. Right? So there's a lot of hard skills that we address within our programs that are essential to companies today. So you may be wondering, well, I hear all this stuff about data science. Is it really business analytics, or do companies need data science? And so let me just tell you what the similarities and differences between these two are, right? So this is just a definition that I picked up from Wikipedia. I could have used almost any definition of data science you could think of. So let me just walk you through it. It's an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data, and apply knowledge and actionable insights from data across a broad range of application domains. Now, let me show you what the difference is if we do the definition for business analytics. It's the same exact thing, only the last few words are changed to solve business problems, right? So all the first part is the same. And again, I could use pretty much any definition of data science interchangeably. It's just a matter of solving business problems, right? It's a focus on that. So that's really how I think about business analytics, and the way I think you should think about business analytics as well, is just data science solving business problems. Now, let me give you a tangible example here, right? So this is a pretty standard data science problem or machine learning problem that you would see if you Google machine learning, right? I'm trying to understand how I would classify pictures as either being a dog or not a dog. Sorry, a cat, not a cat, or a cat, right? That's what it says. All right, so that's an interesting problem for sure, and pretty challenging, actually. It's a lot more difficult than you would think for a computer to figure this out. It's pretty easy for humans, but for a computer, it's not straightforward, right? And I listed at the top there, this is called a supervised learning problem, because we have these labels and we have the data. The data is the picture, right? And so we know what the right answer should be. Now let's see if the computer, the machine learning algorithm, can pick up what the relationship is between that picture and the label that we've attached to it, right? Now let me translate that to a problem that would be relevant in a business analytics domain, right? It's actually the same type of tools that you're going to be using here, but here the problem might be a simple one of, let's check the quality of our product, right? And our product in this case could be screws, right? So these screws have defects. We want to make sure that if there's a new batch coming through, that the number of defects is very low, preferably zero, but low for sure. And so having somebody dive into that and do a little sample is probably going to be pretty inaccurate. Having somebody do checking of all of them is not going to be possible either, because it's just too inefficient. But a machine learning algorithm can get through much larger samples very quickly and see what the defect rate is in a batch of screws, for example. Right? So that's all the difference. We're less interested in cats and dogs and more interested in business problems. Okay. So I hope that gives you a starting point. So that's one piece of my answer. I want to talk a little bit about the 4 levels of business analytics, kind of to expand on your understanding of what it is and what it can be used for. So I'll start with the first 3 and then tell you what the 4th level is, or the way I think of the 4th level. So this is a type of graph or figure that you'll see very commonly when people talk about analytics. It's often referred to as a analytics maturity curve. It basically tells you something about how far along an organization is in terms of their use of analytics to support decision-making, right? There are many companies that are still in the first phase, right? Which is, descriptive analytics, which is basically just trying to understand your data, summarizing it, visualizing it, and so on, right? Just kind of seeing what has already happened. Then predictive analytics is about taking that information and trying to make predictions about the future, possibly also understanding why things happened. And then finally, it's prescriptive analytics, which is what should we now do? So we've got these predictions from our predictive model. What's the next step? What's our decision, right? And in our context, it would be, what's the business decision we want to use this for, right? There is a 4th level. I'm going to come to that in a second. All right. So let me just talk about descriptive analytics again. Summary statistics, plots, all those types of things, very straightforward, often grouped by, right? So we might want to know this by geography or by gender or by age or whatever it might be. And so examples are simple things like averages, histograms, and so on, right? Now, this is where tools like Excel and Google Sheets and Tableau and Click, they'll shine in this area, right? They're very, very good at that. They have very, very easy learning curves. It's not hard to get up to speed with these things. That doesn't mean it's not effort, right? But pretty much anybody in business knows and uses Excel, and many of them are pretty able to get up to speed with Tableau as well, right? And so that's really useful. It really helps you to talk about the data. And that's, of course, the key requirement to even start thinking about analytics, right? Useful, but definitely not sufficient in today's world. I just want to emphasize one thing here, which is the importance of tools like Tableau and also visualization in Excel, right? So I want to talk about why is it so important to do visualizations. You've all heard the saying, you know, a picture is worth 1,000 words. And in many cases, that's absolutely true. You might have actually seen this particular picture in a statistics class. This is a very famous quartet of pictures called Anscombe's quartet, because there's a lot of similarity between the descriptive statistics of these data sets, while the pictures are actually completely different, right? So this picture over here, for example, clearly suggests a strong nonlinear relationship. This probably looks like an outlier. And the fact that this even has a line here is mainly due to this weird point over here. Right, so this is a very famous example from statistics. It's a little outdated in some sense. So they recently came up with a follow-up to this, which they call the datasaurus. If you look at the means and standard deviations on the right, even the correlation, they're all the same up to some numerical rounding, right? But these scatter plots are all completely different. Okay, and so this is just to emphasize how important the idea of visualization is, because just descriptive statistics are usually not sufficient to really understand what's going on in the data. Now, it's very unlikely you're ever going to see a plot in your actual business data that looks like a dinosaur, but it might look really weird. Okay, and so it could be a completely different implication of what's actually going on in your data if you haven't visualized it and only do basic descriptives. All right, so here comes my first, about to get into my first poll question. Right? So this is clearly a visualization of bar graph. I'll give you a bit more context about what is actually going on in this slide. But let me just tell you before I ask you the question, what you're seeing here is sales conversion rate after people have seen an ad after a Google search. Okay, so I'm going to go to Google. I'm going to type in search terms, and then I either see an ad, in this case for a car, or I don't, right? So I might be a person that puts in some search terms, doesn't see any car-related ads. I might see a retailer or a dealer ad, right, for a car. I might see a manufacturer ad, let's say Ford or Tesla or whoever, or I might see a combination of both, right? So maybe a local dealer that shows me specific, Honda Civic or something like that, right? And so this graph clearly has a pattern to it. And so my question to you is, based on just the graph shown in this slide, would you conclude that Google Ads work? Okay, so we're going to start the poll. Give me 1 second to start that up. Oh, you already started it, Nancy? Great. Okay. Yep, so I think I can. Thank you very much. Oh, so I don't want to show you what you're answering yet. So everybody just put in your answer. Just don't think about it too much. Just put in an answer. Okay, and just your gut instinct. Okay. Let me give me 1 second here. All right. Okay. So I'm going to end polling. And let's see, share results. What does that look like? Here we go. All right. Okay, so here are the results. So 75% of you said yes. Yes, this does show that Google Ads work. And 25% of you say no, it does not. So I think the rationale, I expect the rationale for why you said yes is pretty obvious, right? You see that if you don't see any ads, there's basically no sales conversion. If you see retailer ads, you see some. If you see manufacturer ads, there's some more. And if you see a retailer and manufacturer, it's even higher, right? So that is strongly correlated. Let's put it at least that, right? Strongly correlated a strong correlation between Google Ads and sales. Somebody who said no, can you give me an indication, and please feel free to unmute, why you said no? Anybody comfortable doing that? Okay, maybe you're just shy. All right, so let me give you the backstory then. So this is from an executive retreat a number of years ago. It's always been kind of difficult in the auto industry to get really good data that links advertising to sales, because in the US, you have the manufacturer of the cars, then there's the dealership that they work with, and then there's the consumer. And these dealerships do have arrangements with these manufacturers, but it's not the case most of the time that they can enforce data sharing. Okay. In addition, it's sometimes difficult to track if a consumer that actually came into a dealership and bought a car actually saw the ad in advance, right? So at this executive retreat, they talked about how they were able to get around some of those issues, and they were able to link whether or not somebody saw an ad, I believe it was in 30 days, before they did or did not buy a car, right? Okay. So as soon as they presented that at this executive retreat, everybody was very excited. Wow, we've shown that Google Ads work. And not only that, we see that if we have both retailer and manufacturer ads, that the effect is even larger, right? So you could call this an interaction or a synergy effect, right? The combination of retailer plus manufacturer ads, doing those together is more than the sum of the individual pieces, right? 14% is more than 3 plus 5%. So everybody was very excited about that. And so they were talking about this for a while, again, all very excited, until somebody in the end at the back of the room said, I'm a little confused. Can you tell me why somebody who goes to Google might not see any car-related ads? And so people thought about it for a second and said, well, Google doesn't do this stuff randomly, right? They actually think about it. In fact, if they did it randomly, they wouldn't be Google, right? We would have never heard of Google. They actually are pretty smart about how they target these ads. So if you don't see any a car-related ad, it's probably because you didn't put in any car-related search terms, right? And why might you not put in any car-related search terms? Because you're not interested in buying a car, maybe? Now, what if you put in, a Ford Civic, right? Yes, at that point, it's pretty likely you're going to see an ad for a manufacturer, right? Honda, presumably, or maybe a competitor could also be. What about if you put in Honda Civic Pacific Beach or La Jolla? Then you might get an ad that shows a retailer and a manufacturer. Okay. So this person at the back of the room said, so interesting. So if I'm not interested in buying a car, I don't put in car-related search terms and I don't get to see car ads. But if I am interested in buying a car, I do put in car-related search terms and maybe even a location, and then I do see car-related ads. Okay. So unfortunately, what this shows is nothing about the effectiveness of Google Ads. Because what it shows is that Google's smart and it knows with its algorithms quite a bit about you. And so if you're not interested in buying a car, you don't see car ads. If you are interested in buying a car, you do see car ads. And so now the difficulty is in disentangling, is it the ad or is it the targeting algorithm, right? And there's no way to disentangle these two from this data, right? There are ways to do that, but just not with this data. Okay, so if you get anything away from this class, I hope it's that. Always to be careful, even though these visualizations are great, you always want to take a step back about how exactly was the data generated. And then think of your conclusion, if you're really as confident about whether this is a causal relationship, yes or no. All right, now I know this was a bit sneaky, I kind of jumped it on you, but it is an incredibly important topic. All right, so that's level one, right? We have to be able to understand our data in its basic level, visualize it, summarize it, and so on. The second piece is predictive analytics, using data to predict, using data you have to predict data you don't, using statistical and machine learning models, right? And so what do I mean by data I don't have? I don't have data about the future. I don't have data about regions where I haven't done anything yet to generate data, right? So that's what the models are really helpful for. So I could be trying to get at purchase probabilities, demand and inventory levels, a customer churn rates, right? Whether somebody might leave my company as a customer, yes or no, whether parts might fail, and so on. So lots of different things here. So just a very quick overview of some of the methods that are very widely used in practice, starting with basic heuristics. So you may have heard of RFM, very widely used in practice, very simple, but still quite effective. What I'll call analyst-driven models or statistical models. They technically also fall under machine learning, but they're often referred to this way. Linear regression, logistic regression. And to do those well, you really need a lot of domain expertise to do them well, right? It's not data driven. And then the final set is what I'll call data-driven models. And that includes everything that you've probably heard of and seen related to machine learning. So decision trees, neural networks, including deep learning, natural language processing, and so on. Right? So lots of tools in that space. Now, to be able to use these effectively, there are a couple of things you must be able to do. And one of those is directly related to the second poll question, right? So here's the question. Take a look at the graph. It has on the vertical axis sales and on the horizontal axis price. Okay, so as we see that as price increases, sales go down. Pretty much what you'd expect from an economist would expect this always, right? So which region has the strongest correlation between sales and price? Is it region 1 or region 2? So this is the second poll question. And so what let's see, stop share results. Here we go, launch poll. All right, so I just launched the poll. So please tell me in the poll whether you believe either region 1 or region 2 exhibits the highest correlation between sales and price. All right, let's see what you came up with. So this was another kind of sneaky one. So about roughly half of you said region 1. The other half said region 2. And let me tell you that actually, technically, neither answer is correct. I know that's a little mean. But basically, these two lines have exactly the same level of correlation. Okay. Now I can definitely see where you would come from. So you might be thinking about positive versus negative correlation. So the strongest correlation generally we think about in absolute terms. The level of correlation between both of these series is exactly the same. And I know that because I simulated the data exactly to be that way. So what you're looking at potentially in this one right here, right, this series right here, is that it has a steeper slope, right? And that is true. But the steepness of the slope does not tell you necessarily something about the strength of the correlation. In fact, I could have a slope that is almost exactly like this, that could still exhibit a correlation or have a correlation of the exact same level as the other two. Okay, so correlation by itself doesn't say anything about the steepness of the slope. To be able to establish that, we need another tool, right? And that's what linear regression, for example, is fantastically good at. So what I'm trying to get at here is you can definitely apply machine learning and various other things because it's not that hard to get started with it. You can just run something, but it's really important that you understand some of the basic statistical concepts underlying these models as well, right? We don't want you just going off and running stuff. We want you to have a solid understanding of what you're actually doing, because at some point you're going to have to explain it to somebody else, right? And especially if you have to explain it to either a technical person or a non-technical person, both of those audiences are going to have strong difficulties in how you convey this correctly, right? To a technical person, it might be easier actually. To a less technical person, you still have to be able to tell them why this is a good tool to use and what it does under the hood, kind of at a high level, right? So that's again a little bit of a trick question, but it is a very important concept to understand the concept. Yes, go ahead.
Yeah, if you go back to the other one slide.
Yes.
What I fell prey to was the fact that the sales two seemed to be denser and more tightly packed. And
yes.
If they had had the same approximate slope, and yet region 2 was, sales 2 had been denser, so instead of pulling every point down, if you had rotated the slope, would that have been a higher correlation?
So it is indeed true that, especially the third line that I just created, right, this one up here, that will only work if the variance is also smaller. Right. So you're absolutely right. You spotted that very nicely. That there is a bit more variance in the third, in the scatter plot for region 1 than there is in region 2. Right. And so basically, what correlation is consistency of co-movement. That's all it is.
Right.
And so the more strongly it, if one goes up, the other goes up. If one goes down, the other one goes down, or the opposite, right? The negative, one goes up, the other one goes down, super consistently. That's how you end up getting with really, really high correlations, right? But it does have to do also with the density. So well spotted. All right, and then as we just talked about, or I alluded to when we talked about the Google Ads example, the concept of causality, right? What's causing what? And this is incredibly important because you do not want to tell a manager, hey, if we do more of this, right, we do more Google Ads, this is how much more sales we're going to get. And then you invest millions and millions of extra sales in extra Google Ads, and it doesn't pan out, right? Then somebody's not going to be very happy with you. Right? So being able to understand what does and doesn't drive, and what's a reasonable assumption around causality and what isn't, is incredibly important. All right, now, what are some of the most kind of used methods in practice? Like I said, you've probably heard of neural networks and deep learning because, anytime you hear about AI, oftentimes they're referring to deep learning and neural networks. But other tools such as random forest and decision trees are actually still more widely used. And logistic regression, which is very similar to linear regression, if you haven't seen that before, is actually pretty much used by any company that does anything with analytics. Right? So really, really important tools. Now, I do want to spend a little bit of time talking about neural networks because they are very cool. If you haven't seen them before, I want to give you a little bit of a sense of what they're about. At their basic level, a neural network is just a really fancy, highly nonlinear regression model. A highly nonlinear regression model. So what I want to do here is give you a visualization of what a neural network would look like with something that you probably have seen before in maybe a stats class, right? So here at the top right, you see an equation that represents a linear regression model. So how would I write that up, or how would I visualize a neural network version of that? Well, pretty much the simplest neural network that you can create looks like this. Right? Now, we don't have a lot of time to go into the details here, but the main thing I want you to see is that here on the left, x1 and x2, those are just my explanatory variables. And on the right here, we've got y, which is just my response variable or dependent variable. Right? And the stuff in the middle is just linking them together. Right? So this is actually very, very similar. This graphical depiction is very similar to a linear regression model in this case. Now, of course, that's not where these things get interesting. I mean, why would you set up a neural network to estimate the same thing as a linear regression? Right? Why not just estimate a linear regression? Where the real benefit of these things comes in is when you make them bigger. Right? And so this is just still a tiny neural network, but you could see these B0, 1, B1, 3, these are all, you can think of these as coefficients in a linear regression or a logistic regression model. Now, this is still, like I said, a tiny neural network. You can blow these up a lot. In fact, some of the models that you might have seen or used even on Google, for example, to classify a picture, like what is this? They could use up to millions of these weights or coefficients. Right? So where they get really big, they get super powerful as well, but they also need massive computational resources. So I want to just show you a couple of application areas of these that you might already be aware of. For example, recognizing handwritten numbers is not straightforward for a computer, so it needs help. And so translating those pictures into, is that a 2 or is that a 0, is very, very useful. Autonomous driving, this is one of the biggest application areas at this moment. So think about the Teslas, Ford, you name it, right? Pretty much everybody seems to be working on autonomous driving these days. Facial recognition, which is incredibly good. In fact, facial recognition by computers is better than humans are on average, right? Already. And that's only getting better and better. Now, just to give you an example, and I don't want anybody who has sensitivity to kind of these types of moving pictures to get nauseous. So I'll put this out very quickly. So this is a handwritten 8. And how does the computer take that handwritten 8 and use it for data analysis? Well, it first has to transform it into some numbers, like actual numbers. And those numbers here are the grayscales, right? So what you see kind of as the picture switches between the 8, the handwritten 8, and these numbers, those numbers are what are going to allow a supervised learning algorithm to link that picture to an outcome, right? So we provide the label that is an 8. Then we take the picture, convert it to lots of numbers. And so basically what you see here, these are all the numbers, the grayscale numbers. You can think of that as columns in a data frame that are going to be used to predict whether this is an 8 or not. right? Again, supervised. So we see the picture, we transform it into data. We say to the computer, this is an 8 and this is not an 8. And then we let it run, okay? And so that's, again, a neural network model with input features and outputs. And so it's just trying to make the connection between the data it derives from the picture and some output, okay? Now, you can imagine that this is really hard to do because there's so many different columns here with their own weights. And so what does it mean if a grayscale goes up by a number or down by a number? Who knows, right? These models are really black boxes. And so they're very, very good at prediction, but not very good when you're trying to understand what's going on. So let me just get rid of that because it makes me actually nauseous if I look at it for too long. So this is super, super powerful technology. You can imagine, just think about a Tesla driving down the road with its auto steering feature on. Of course, you can see the two lines here that are the lines that it's trying to stay in between, but it's also taking pictures or video of everything that's going on around it, converting that into numbers, just like we saw on the previous slide, feeding that into a neural network algorithm, right? It's not re-estimating it, it's just pushing it in and generating predictions of what everything around the car is doing. When it has a good sense of that, it knows how to react. If somebody's walking along the side on the sidewalk, not a problem. We're not predicting with any high likelihood that that person is all of a sudden going to jump across the road, right? But if a car starts swerving into your lane, the model can try to predict that in advance and say, hey, we need to stop. Okay, so very, very powerful technology that can work very, very quickly these days. Just to give you a simple example of how this would work, imagine the following simulated data, right? So just use some Python code here to simulate a little data set, visualized it. And if I were to give you that, you may be able to figure out that this is sort of a cosine wave, and you'll be able to model it pretty quickly. But if you don't have that background, it might not be that easy to figure out how you model this. So first thing you need to do if you want to estimate a neural network is standardize the data. When you get to the class, you'll see very much why that's important. And then I'll start estimating a neural network, right? So this is just some Python code. Details are not important, but I'll show you that if I start with a small neural network, it's not going to do very well. But then I don't have to know anything else about the pattern. I'm just going to start adding more and more nodes to the neural network, and it starts getting better and better until with 20 nodes, it's almost a perfect reproduction of the original data. Right? So that's, again, no additional information. I've just made the neural network bigger and more flexible, and it's able to reproduce the pattern of this data exactly. All right. Now, these neural networks do have very important drawbacks. And so I just want to highlight one of those so that you don't get overly enamored with them. They're very susceptible to overfitting, meaning that even if there are semi-random patterns in your data set, particularly your training data, it could fit those very, very well. The problem is that these semi-random patterns that are in your training data may not exist in any other data sets. And so when you try to do prediction for something else, some other region where you haven't had customers before, it's actually going to end up doing incredibly poorly. We'll get into all the details later, of course, not today, but in another class. And then it can be very difficult to explain the results. So imagine that you're a bank and you have denied somebody a loan, and they come back to you and say, it's because of my race, or it's because of my gender, or it's because of my sexual orientation. How would you explain to them that this neural network with 1 million nodes is or is not actually using that type of data? Right? It's almost impossible to do that. And so various companies have gotten into a lot of trouble with that. A pretty famous story from a couple of years ago was the Apple credit card, where some people found that the male in a heterosexual partnership was getting vastly higher credit limits than their spouse. Right? And so these are a couple of pretty famous people. You may not know DHH, but he's the creator of the Ruby on Rails framework. And then Steve Wozniak was one of the co-creators of Apple. Right? And so of course, Goldman Sachs says, well, it can't be that, right? It's the algorithm doesn't even have that data, but maybe it's using a proxy for something that is related to gender. And based on that, it's still actually going to be telling you something that is based on gender. So very, very difficult. These algorithms are great, but understanding is at least as important in many contexts. Let me give you another example. This is kind of a funny one. A machine learning algorithm was tried to differentiate huskies and wolves. And it turned out it was actually very, very good at that, until they figured out what information it was actually using to make the distinction. And it turned out that for the wolf pictures, there was almost always snow in the background, whereas for the huskies, there was not. And so without that information, the algorithm actually did very poorly. It was just picking up on this information, because what do you know about what information it's using, right? that was picking up on the snow and actually using that to classify one versus the other. Okay? So imagine taking a wolf and putting it on grass. The model is almost surely going to predict that that's a husky. Okay? So there's lots of kind of caveats to this, which only goes to show that you really need to have a pretty good understanding of this before you should be comfortable using these things in practice. All right, now, a couple more minutes. Let me just wrap this up. So predictive analytics, prescriptive analytics then is the last phase. What are we going to do with this? Right? We now have this prediction. Now, what's the decision that we have to make? Right? And so that's an incredibly important part. There's lots of areas where this is important. It can include things like simulation and optimization tools. And targeting, this could be really useful. Like, who are we going to target based on their past purchase history, right? Who should I be making an offer for an art book? If they have purchased lots of art books in the past, the model says, well, this might actually be a really good person to target with that, right? So we can actually look at the results from our models to indicate what we should do now. So it could be as simple as the decision rule. If the predicted probability of response is higher than X, then we should target this person. Otherwise, we shouldn't. Similarly, if you look at maintenance for big industrial projects or wind farms, right? The maintenance of those things is incredibly expensive. And so if you just do kind of a standard every X month maintenance schedule, you're probably visiting some of these wind trees far too infrequently and some too infrequently. But if you have sensors in those things that show heat and maybe smoke and other things, and efficiency, then you might say, hey, you know what? Based on the prediction and the data we have and the prediction from this model, it looks like this thing might fail within the next couple of weeks unless we send somebody out there. Right? Whether the other ones are just moving along just fine, we don't need to do anything. And so this is actually Avita Systems. We actually have an MBA alum at that company. Very, very interesting to see what they do with robotics and machine learning, sort of just fly these robots around these big plants just to get additional data, let's say on corrosion on the outside, and just get additional information that can be used and analyzed and be used for predictive as well as prescriptive. Like, do we send out a technician to this facility? All right. Now, the fourth phase is artificial intelligence. Okay, and I'll take 2 more minutes and then I'll get to that and see how it connects to the first 3 phases. All right, now, why I want to stop before we get to that is just to emphasize that it can be also really useful to understand business analytics to avoid magical thinking. Now, there are many, many top executives and CEOs that now that they've heard about artificial intelligence have this idea that if we use machine learning or we use artificial intelligence, that will just magically take care of all our business problems. Right? We don't know what to do in this context. Let's just get AI. We don't know how to do what to do here. Let's just use machine learning. And it's a lot more complicated than that. Right? But it's pretty pervasive amongst top executives. Why? Because they haven't had any training in this. Right? They don't necessarily understand the tools that are there, but they hear and see all of these really hyped up stories about how effective it is, that they're prone to say, let's just invest $1 million in this. Right? Let's just get 50 people and do all of this analysis, get all of these servers or lease them on AWS and so on. And that's not necessarily the smartest way to go. Just to give you a little bit of background of the link between artificial intelligence, machine learning, and statistics, it's actually the case that artificial intelligence is the overarching field which contains machine learning. Now, this is a pretty, at least to me, pretty funny example here. If you've ever done a linear or logistic regression, technically you've done artificial intelligence. In fact, you could even argue that if you have done an if-else statement in Excel, that you've done artificial intelligence. Now, I realize that's pushing it a little bit, but so AI is often overused, okay? Now, you may be wondering, why is it that AI has such a lot of buzz right now? Because it's been around for ages, right? And it used to be that we were trying to create rules and if-then statements and processes all specified by the researcher, right? If a car sees this, then it should do this. If a car sees that, then it should do that, right? And you can imagine that might work in very simple settings, but just imagine the chaos that we see every day on the road. Very, very difficult to make all of those rules. And so the modern approach to AI is let's just infer the rules from the data, right? That's the process. It requires a lot of data, requires very much computing power, but it's much more efficient, right? It's going to get much better insights than what you actually should be doing. So where are we currently with AI? We really have what is called narrow AI. We're not anywhere near general AI. We had a speaker a couple of weeks ago who used to be the head of machine learning at Amazon, and after that, the head of machine learning at Goldman Sachs. He says, it's not that I don't think we can do it or ever will do it. Right now, we just don't have a path to how we get there, right? And so narrow AI is much more narrow, obviously. And I'll give you a couple of contexts of where it can be super useful. All right. Okay, so let me connect the three different phases that we talked about and artificial intelligence. So we talked about descriptive, we talked about predictive, prescriptive. Now, to me, where artificial intelligence gets really, really interesting, beyond something like Google telling you how you might more quickly end your email, is where I can take the insights that I've gotten from these first three phases of analytics and basically wrap a data and automation layer around it so that I can start making decisions, in some cases, even without the input of humans, right? So I think about artificial intelligence for business decisions as a dynamic prescriptive analysis where there's new data coming in, it's being processed, it's being used for prescriptive analysis, and those actions generate new data that gets fed into the front of the loop, gets processed, used for new predictions, new prescriptions, and so on, right? And so this is a role where I would say that for business intelligence, standard business intelligence, these first three blocks are the most usually emphasized. Artificial intelligence, to some extent, just requires a data engineer to lay the data pipelines, if you will. Right? Now, let me give you a couple of really prominent examples because there's only a couple of companies that are really good at this yet. One of them, of course, is Amazon. So Amazon and their pricing, they have so many different products, it's impossible for them to hire people to do all of it. Right? It would just be immensely costly. So what do they do instead? They are constantly running experiments. Right? You might have heard of experiments before in different contexts. This is what's called a field experiment. And usually these things could take weeks to months, but Amazon can do it in a couple of hours. Why? Because they have so many different people looking at these products, buying or not buying. And so they can run these things incredibly quickly. And interesting, what they do with these experiments is they dynamically update them. Suppose that a product has always been priced at $2.99 and they bump it up to $5.99. And after, let's say 100 people have looked at it and purchased, they're like, doesn't seem like people are very price sensitive to this. So they change the experiment so that more and more people see the $5.99 number because that seems to be the best one anyway. And then based on that, they can very much more quickly get to an optimal price and then keep doing that, let's say for a couple of weeks. And then they run another automated experiment to kind of see if the price needs to be adjusted. So this has multiple different names, the process that they use here. Multi-on banded is one, reinforcement learning is another. And the entire pricing process at Amazon in this aspect is fully automated. Another company that some of you may be familiar with and others not is the Ant Group. It used to be called Ant Financial, an affiliate of Alibaba. They have a platform for consumer lending, money market funds, wealth management, health insurance, you name it. And what they claim is that they serve 10 times more customers than the largest US banks with only 1/10 of the employees. And how can they do this? Because basically there's no human on the critical path for operating activities. So there's no manager that has to say, I approve a loan or not. You provide the data, the computer, the algorithm says whether you're a good risk or not, and makes the decision. Right? Of course, there's humans involved in setting up how these decisions are going to be made. But once they've set in their rules, the process just happens automatically. There's no employees providing financial advice. Right? There's no one to authorize medical expenses or insurance claims. And so because of that, they have grown tremendously, tremendously fast. They're currently in a bit of trouble with regulation, but that model, I think, is going to catch on in many, many different areas. All right, so let me wrap up. Why do you need business analytics? Well, first and foremost, companies need that to create value from data. And I give you a sense of why it's business analytics and not necessarily data science per se that is of most importance here, because what we really want to solve in many cases is the business problem, but we use the same tools. So you need an understanding of business analytics as well to help avoid some of this magical thinking around machine learning and AI. And then ultimately, business analytics uses data, machine learning, and AI to create value for companies and customers, right? That's what it's all about. All right. So I want to thank you for your attention. If you have any questions, I'm happy to stick around and tell you a bit more. But I really appreciate your time and participating in this masterclass. Thanks, Tim. Feel free to speak up. Happy to answer any questions you might have.
Yeah, I was just going to give another example that I know of is that in the airline industry, they will reroute planes to different gates based on prescriptive analytics of and knowing whether a particular high value customer on board might miss his next flight. And so they'll move, airlines will be assigned a gate that will help that particular or those particular high value customers make their next flight, even if it's at the expense of other customers.
Right. And I would in most cases, I would trust the computer to be able to reroute everything at that point, right? Suppose it's a last minute thing. Are you going to trust the air traffic controllers to say, oh, let's move all these 50 flights around? Imagine it's the Chicago hub or something like that, or LAX. Right. And so quite likely, so it's still good to have humans there in case there's something weird that they had that wasn't anticipated. But yes, they can probably do that much more quickly and efficiently than a human could, and with lower risk.
Hi, I do have a question. So regarding the course only. So like how much Python do you expect from your students that they should be aware? Like we are coming here to study. So like how much should we be that much aware? Like I know a basic of Python, but to be very frank, I have not used that much. So this looks little nerdy and looks so scary to me as of now. It's more like the data scientist, not the business analytics thing. So like I was interested, I am interested in AI, but like how much should we be aware about the AI, the neural networks before we come to be joining or we come to the classes or something like that?
Right. No, so what we expect is energy and enthusiasm above everything else, to be honest. Right. And those of you that I think Tim, you're already signed up for the Flex program, right? So you've probably already had emails saying this is the prep work that you can already get started on. Right. So if you're a Python whiz, you're just going to race straight through that. If you haven't seen it as much, then this is kind of starting from the basics of Python, learning the basics, the structures of it, right? Learning a little bit of pandas, learning a little bit of NumPy, but just at your own pace, right? So the program start date is 3 months away. So you have time to kind of process all of that at your own pace. Then we're going to have a class at the beginning as well. So some people in the program are going to have more technical backgrounds than others. Some are going to have more business context than others. But what we need is everybody to be able to bring technical expertise to business problems, right? So there's two parts to this. So the main thing I think that is, and we've done this for a number of years now, the full-time program, the Flex is new, but the full-time program, time and time again, we see that it's not necessarily just the GPA or the GRE or anything like that. A lot of it is driven by enthusiasm. And why is that? Because there's so many new concepts that you have to deal with in different contexts that you haven't seen before that nobody's really kind of fully prepared to do the last classes, right? And you wouldn't expect that, right? And so that's why we have the program all built up so that you can start at your own pace, right? With these types of technical pieces. Then you're going to jump into the first classes where we're going to bring basic stuff together. It's going to see just not this basic Python, but how do I apply that to solve a business problem, right? A simple business problem. And then over time, we build it up, right? So our program differentiates from some, let's say, particular data science programs is that we don't have statistics 1, 2, 3, or machine learning 1, 2, 3, right? We have customer analytics, we have business analytics, we have supply chain analytics, which uses all the same tools, but starts from the problem. And for me personally, I remember when I was taking statistics classes or a math class, and the instructor said, you know what, you may not understand what this is for, but next quarter you will, or maybe the quarter after that, right? Just bear down and just follow through, and then you'll get it eventually, right? And I hated those. Right? I mean, I like math and I like stats, but those classes were just brutal for me. And so we do it the opposite way. We start with, this is a problem we want to solve. How would you do it? Right? What's the data? Okay, let's think about the data. Now I'm trying to solve it. So what type of an output do I need? Okay, what type of a method might go with that? And so we sort of work backwards from the problem to figure out what the right tool might be. And in some cases, they could literally be just a bar graph, right? So think about an experiment. If an experiment is well set up, we should be able to infer from the experiment what the causal relationship is, right? So imagine that Google Ads example I showed you, right? If that had been generated by a random experiment, right? So you go to that site, no matter what your search term is, you randomly get assigned a car ad or not a car ad, and then we see these results, then I would have been perfectly comfortable saying, yes, Google ads work, and this is how much they work, right? And so the only thing you need to do there is make a bar graph. That's it, right? So in some instances, it's very simple, but in some instances, yes, it can get quite complicated, right? And so the neural networks, that's one of the more advanced techniques. You won't necessarily see those in the first quarter, but in the second and after quarters, you can see a lot of that. But it also depends on your interest. So within the program, you can take some MBA classes as well if you want. It just depends on how you want to round out your profile. That's not something, I think you can take 12 units of courses outside of the MSBA program. So that's actually quite a bit, but it depends on what you want. There are also some people that say, you know what, I want even more technical. So let me go and take some electives with computer science. And that's completely fine too. So we have people with varying interests within the program, and all of them end up working out quite well. So I wouldn't be overly concerned about that. I'm happy to talk to you about this offline or online, but on another online, sorry, if you have questions. But if I can give you plenty of resources to kind of see if you would be comfortable with things.
All right. Yeah. Thanks so much. Yeah.
Sorry for the overly long answer.
Yeah. Yeah, it was quite descriptive, I guess. Thanks. It made me feel a little comfortable. Yeah. Thanks. Yeah.
Honestly, I think, if you look at a traditional, let's say, marketing manager these days, right? Often that their requirements there would include things like AWS certification or some other technical piece, right? Because a traditional marketing manager doesn't exist anymore, right? Not in the way they did 15 years ago. I remember when I was at the Kellogg Business School before this, and they would joke about Kellogg students because Kellogg is really big on marketing. You go there to learn how to design logos, right? That's how people thought about marketing like 20 years ago. It wasn't quite fair, to be honest, but that's how people thought about it. And that's long gone, right? The marketing majors at Kellogg take some of the classes that we also have in our MSBA program, right? So they learn about customer analytics, maybe at a different level, right? But they also learn about how they utilize and how they direct teams that are based on analysts. Right? So there's all kinds of different levels. And I think even within the program, there's very different levels of how deep somebody wants to go versus somebody else. So there's flexibility.
True. That's true. Yeah. Same with us. Like we do have the program analyst profile, but we do use like Tableau, Power BI.
Mm-hmm.
Yeah. So it's not just managing, coordinating. It's more towards now using the tools and how you can extract the information out of those.
Yes. And those tools are great, by the way. I have nothing against those tools. It's just that there's a whole world of opportunity out there that requires a bit more knowledge than you can do and things you can do with just Tableau or Excel.
Sure. Yeah.
Any other questions? Okay. Well, I also don't want to keep Nancy too long because she's been a sport kind of tagging on later in the evening. If you have any questions, just reach out to us. So Nancy already gave you the email. We're happy to tell you anything you want to know about the program. We're excited about starting the Flex program. I think it's going to be a great opportunity for working professionals to kind of, I don't remember the expression, but kind of, it's not break their teeth. What is cut their teeth? Isn't that the expression? Cut their teeth on kind of some analytics.
Bite your nails, I guess. Bite your nails. Yeah. I don't know.
So I'm from the Netherlands.
I guess so, like bite your nails. Yeah.
So I'll sometimes in class do charades because I try to use these English expressions that I don't really know that well. So a little bit silly, but there you have it. If you have questions, like I said, if you have questions, just reach out to us. We're happy to interact with you and tell you more. So thank you very much for your time this evening. We will share the recording with you as well. So if you want to get back to it and see any specific pieces, and have a good evening, everyone.
You too. Bye. Nancy, I do have one question from you.
Yes.
Feel free to ask.
Approximately like how many students have enrolled
For
in
the
the
Flex
business?
weekend? Or for the full-time?
How many?
For the full-time or for the part-time?
Part-time, like the Flex one, because I am gonna enroll in the Flex one, so that's why I was interested.
Yeah. So right now we're I'll let Professor Vincent maybe tackle that.
It's interesting. So it seems like the Flex programs tend to be much later in terms of people applying than our full-time programs, right? So for full-time, I think we've already had more than 2,000 applications, and we're looking at somewhere in the 80 to 90 range of students that will eventually be in the program. This is the first year for the Flex Weekend, so we definitely don't want it to get anywhere near that big. So we're anticipating somewhere in the 30 to 40 range.
Oh, okay. Okay. All right. Yeah.
So it'll be
Thanks.
quite a small group. We anticipate that we'll be able to kind of get you guys all connected and working with each other.
Yeah, that's
smoothly.
what I was thinking. That's what I was
Yes.
thinking. Like after coming like on Saturday class, like but like I would expect like 30 or 40. That's much more better for me personally.
Yeah.
Yeah.
No, and especially the first year, I think that's a great number for us to have. And we're very, very confident in the value that we can create, but it's also something we need to get the word out, right? And so we don't have
Yeah.
infinite advertising budgets to let everybody know about everything. So we want to keep it reasonably small for the first year, and then let's see how things go and develop. But we are very, very confident about the value that we generate.
So do you guys expect like these classes will be in person soon, or
Yes.
it will be online? Yeah.
So there's a little bit of variation. The university has said, based on current models, all projections, that everything will be fully online at its normal capacity for the entire university, starting in fall. Right, so fully back in person, everybody there. The only exceptions would be people like, for example, right now in India, that are not able to get their visas. Right, we would need to treat them more flexibly, obviously. The Flex program starts in summer, right? So early August. I think the first date might be like July 30th or something. But we are currently planning to have the sessions on the Saturday. So there's going to be some extra sessions. The sessions on the Saturday will be in person. And then any other sessions will be on Sunday, but remote.
Okay. It will be
Okay.
something like 9 to 5, like on Saturday.
I think we're doing 8 to 5.
8 to 5. Okay.
Yes. So you'd have to get up a bit early. But for me, that's very early. But it is what it is. I think that's the best time for a lot of people. I think it's what our other programs do as well. So we're sticking with that. But the plan for the program is, so the summer is a bit more intense, but then after that, it's one Saturday every other week. And suppose that you, for whatever reason, cannot attend, then you would be able to Zoom in, right? So up to 50% of your time could be connecting through Zoom. We hope that people come as much as possible in person, because I still think that's the preferred medium.
Yeah.
But if that doesn't work for you on an occasion, for whatever reason, but you do have access to Zoom during those times, then you can Zoom in, right? Everything will be recorded, of course, as well. But I really value class participation. That's one of the reasons why I really like to see the videos too, right? Because I want to see you. I want to see you interacting, and that's just a little bit harder on Zoom than in person.
Yeah, that's true. And how much, within how many days could I expect, like if I submit my application today, so how many days should I expect to receive a response from you guys?
Nancy. So Nancy is in charge of all of that.
Yeah, I would say give it at least like a week or two, because as I had explained in the video, like in the beginning, your initial application, it's reviewed, and then you're invited to an interview. So in order to kind of progress, so in order to be invited to an interview, I wouldn't expect it to take more than a week. That's been kind of like the time frame. But then when you get that interview back, it gives you, we usually give you like 10 days, but the longer you take, obviously, it's like, then at that point, it takes longer for us to review as an admissions committee. But if you get it back within 3 or 4 days, then, it gets reviewed a little quicker.
Okay. All right. Thanks. Thanks so much. Yeah.
So a couple of related questions. So one is, how many classes per quarter? So it's 2. So 2 classes per quarter. So especially the first quarter, let's see. Yes. So summer through fall, you will basically have to do two classes per quarter, because they're core classes. Then after that, it's 1 core class, which is mine in winter. And then after that, suppose you're currently planning, hey, I'm just going to sail this through at exactly the pace that we recommend. Great. But then something happens. Who knows what that is, but something just takes up more of your time than you had anticipated. Can I slow down the pace? And the answer is yes. That's absolutely possible. That's not a problem in any way. We want to be flexible with your schedule and see how that works. I'm assuming most people don't start out with that anticipation, but stuff happens. And so we want to be flexible around that. But the standard load is 2 per quarter. And now the difference between MBA, somebody asked the difference between MBA and Master of Business Analytics. Well, one, of course, the Master of Business Analytics is 1 year. Okay. So we do also have some analytics related classes in the MBA, but they don't go quite as deep, right? So if you want to be a marketing manager that understands analytics, then you can be, or a manager in any area, then the MBA might be a good choice for you. If you want to be able to do some of the analytics too, and really help support decisions with all the power of data, then the MSBA is the best option for you. Okay? But that's just a very high level answer. So if you want to talk to us, you want to talk to Nancy, that would be a great person to talk to, give you a bit more of a flavor of exactly what the differences are, right? So the MBA is longer, but it's also much, much broader, right? So if you really want to understand finance and accounting and marketing and management and operations, right, in detail, to really be a well-rounded business professional, well-rounded manager, and maybe you have ambitions to be a CEO one day, then an MBA is a really good choice. If you really are enthused about data and you want to figure out how to use that, and then ultimately you're also going to climb the ranks and maybe become a manager as well at some point in the future, right? You may not want to do a lot of coding for 10 years straight or something like that, right? But it's a really great place to start, because if you have a good understanding of data, I think that's one of the key skills you're going to need, even at the highest levels of the organization into the future. Again, that's a very high level answer. You probably have lots of sub questions to that, but we're happy to kind of connect with you more on that.